Welcome all. In last lecture we have seen demultiplexer introduction, demultiplexer types and study of demultiplexer IC 74155. Today we will see what is demultiplexer tree and design of demultiplexer tree. Similar to multiplexer, we can construct the demultiplexer tree, and the demultiplexers having more number of inputs can be obtained by cascading two or more demultiplexer with less number of inputs. This is called as a demultiplexer tree. Means we can construct 1:4 demultiplexer using 1:2 demultiplexer. We can construct 1:8 demultiplexer using 1:4 and 1:2 demultiplexer. We can construct 1:16 demultiplexer using 1:8, 1:4 and 1:2 demultiplexer. Similarly, we can construct 1:32 demultiplexer using 1:16, 1:8, 1:4 or 1:2. So we are going to see some of the examples based on demultiplexer tree. So this is the first example in which we have to obtain 1:4 demultiplexer using 1:2 demultiplexer. So first we have to form a truth table of 1:2 1:4 demultiplexer. As the outputs are 4, number of select lines will be 2, that is S1 and S0, and 4 outputs are Y3, Y2, Y1, Y0. So as per truth table, when select lines are 0 0, then data input will appear over a Y0 line, as Y0 line gets selected. When select line status is 0 1, then data input will appear over Y1 line. When select line status is 1 0, the data input appear on Y2 line. When select line status is 1 1, then data input appear on Y3 line. This is how the 1:4 demultiplexer operates. Now for this design we require two 1:2 demultiplexer, each having data input. The data input of both the demultiplexers shorted together to form a common data input line. These are the two outputs of first 1:2 demux, and these are the two outputs of second 1:2 demux, which will form 4 outputs together. Now as 1:2 demultiplexer is having only one select line, both the select lines of demultiplexer shorted together, named as a single select line S0. Now we require two select lines, as we have to form 1:4 demultiplexer. Now to form another select line, we are shorting enable lines of both the demultiplexer to form S1 select line. Now S1 is given through NOT gate to the first demultiplexer, and it is directly connected to enable terminal of second demultiplexer. Now this S1 will make enabling or disabling of both the demultiplexer, so that any one of the demultiplexer will be enabled at a time. Now we will see how this is formed in the next slide. So this is our first 1:2 demultiplexer. This is our second 1:2 demultiplexer. These are the two outputs of each demultiplexer. This is data input line shorted together to form a common data input line. Select lines of both the demultiplexer shorted together, named as S0. Now to have second select line, we are connecting enable input terminal of both the demultiplexer through a NOT gate. For first demultiplexer, the input is given through NOT gate, and for the second, this is not like this, and for second demultiplexer it is connected directly. I will make correction. So for first it is given through NOT gate, and for second it is connected directly to the enable input terminal of the demultiplexer. This will form a select line S1. Now for the first two condition, S1 is 0, by which the first demultiplexer will get 1 input, second will get 0 input. So during S1 as a 0, the first demultiplexer gets enabled and second demultiplexer get disabled. So we will get the data input over any one of the two output lines of first demultiplexer depending on status of S0. If S0 is 0, we will get data input on this Y0 line. If S0 is 1, we will get the data input on this Y1 line, and by default we get 0 over these two lines. And if S1 is 1, then we will get a 0 for the first demultiplexer and 1 input for the second demultiplexer. As the first demultiplexer getting 0 input in the enable terminal, it will get disabled now, and second demultiplexer will get enabled as it is having a logic high input at the enable input terminal. So as the second demultiplexer is enabled now, the data input will appear over any one of these two output lines. Now depending on S0, if S0 is 0, we will get data input on Y2 line, and if S0 is 1, we will get data input on this Y3 line, and we will get a 0 output by default over the output lines of the first demultiplexer. This is how we can design a 1:4 demultiplexer using 1:2 demultiplexer. Now next we will see 1:16 demultiplexer construction using 1:4 demultiplexer. Here we have to obtain 1:16 demultiplexer, so there should be 4 select lines, S0, S1, S2, S3, and depending on status of S2 and S3 and S1 and S0, we will get data input over any one of the output line of the 1:16 demultiplexer. So this is the design. We will see how this design came into the picture. So to construct 1:16 demultiplexer, we require 4 1:4 demultiplexers. These are the 4 1:2. Now here space is very small. I will redraw the design again. These are the 4 1:4 demultiplexers. These are the output lines of each demultiplexers, which will make 16 output lines. Now each demultiplexers are of 1:4, so each having 2 select lines, that is S1 and S0. I will short all the select lines together to form 2 select lines. This is how we can short together both the select lines. Now your space is less, so these are the 2 lines, S1 and S0. Now each demultiplexer is having data input line. Now these 4 data input lines are connected to another 1:4 demultiplexer, so that 4 data input can be converted into single data input line. And this 1:4 demultiplexer is having 2 select lines, that is named as S3 and S2. and this data input will going to appear over any one of the 16 select lines. Now here these S3 and S2 will going to select any one of the demultiplexer, and S1 and S0 will going to select any one of the output line from the selected demultiplexer. So when S3 and S2 are 0 0, then this first demultiplexer gets selected. When S3 and S2 are 0 1, second demultiplexer gets selected. When S3 and S2 are 1 0, third demultiplexer gets selected. When S3 and S2 are 1 1, fourth demultiplexer gets selected. And based on the status of this S1 and S0, any one of the output line of selected demultiplexer gets selected, and this data input will going to appear over the selected output line. This is how we get the 1:16 demultiplexer using 1:4 demultiplexer. This is the final design. So in all we require over here 5 demultiplexers. Next we will see 1:32 demultiplexer using 1:8 demultiplexer. Now here we have to obtain 1:32 demultiplexer. For that we require 5 select lines S0, S1, S2, S3, S4 and 32 outputs. Individual outputs are shown in this column. Now we have to use 1:8 demultiplexer over here. So to have 32 output lines, we have to use 4 1:8 demultiplexers, which will form 32 output lines. These are the 32 output lines. Each 1:8 demultiplexer is having 3 select lines, which are sorted together to form common select lines S2, S3, S4. Now each demultiplexer is having single data input line, which we have to convert into a common data input. So for that another 1:4 demultiplexer is used over here. This 1:4 demultiplexer is having 2 select lines. Here the select lines names are S4 and S3. By mistake here written as S0 and S1, and remaining select lines are S2, S1, S0. These are the S2, S1, S0 select lines, these 3 select lines. Now here the S4 and S3 select lines will select any one of the 1:8 demultiplexer, and S2, S1, S0 select lines select any one of the output line of selected demultiplexer. This is how we can design 1:32 demultiplexer using 1:8 demultiplexer. Now these are the exercises. First one is you have to obtain 1:64 demultiplexer using 1:8. In second you have to obtain 1:64 demultiplexer using 1:16 demux. In third you have to obtain 1:16 demultiplexer using 1:8 and 1:2 demultiplexers. The solution of these problems are available in the TechMax. You can refer the TechMax to solve these 3 exercises based on demultiplexer tree. Thank you.